This is Koz with the MLabs team presenting the closeout video for our Fund13 project titled Static Analysis with Covenant. Covenant is a functional domain-specific language and design framework that makes Cardano smart contracts easier to analyze, optimize, and verify. It separates high-level contract logic from low-level execution details by using a stable JSON-based intermediate representation. This separation of concerns is far more ergonomic for developers. With Covenant, teams can perform static analysis or performance tuning without being experts in the opaque and arcane internals of the Haskell to UPLC compiler or anything similar. In contrast, existing monolithic tools often force developers to fight against a language to stay within execution budgets, making maintenance complex and security proofs nearly impossible. Furthermore, Covenant allows specialists to work on only a particular part of the translation. Perhaps they are interested in front ends that can be used to write this logic, optimization or analysis tools, or code generation. And this means that they can do their work without being concerned about the remaining levels, which is not currently possible or possible at all, or at least straightforward to do. MLabs submitted our Covenant proposal in the Fund13 Cardano Open Developers Fund category. This category aimed to support the development of open source technology, particularly for enhancing the Cardano developer experience and creating developer-friendly tooling. We were funded with about 200,000 ADA. Our project outputs map directly to the category goals. Specifically, we delivered a suite of open source tools centered around a standalone Haskell library that allows developers to build and type check Covenant programs without any dependency on Plutus or Nix. Furthermore, we also provided, as part of those tools, a code generator for UPLC that consumes Covenant's intermediate representation. Over the course of the 5 milestones, we moved from a core-type system to a fully realized serial form, successfully implemented support for data types as well as different encodings, and full support for the Plutus v3 Ledger API. By utilizing recursion schemes and catamorphisms, as well as through the design of the language, we ensured Covenant's totality, which means that the programs cannot loop forever or do something similar. This enables static analysis, which the project promised would be possible. We finally produced the executable tool C to UPLC, which translates Covenant's serial form into UPLC that can be executed. As the vision for Covenant was highly ambitious, we encountered some significant technical hurdles during the initial research and development phases. We quickly identified that our original plan for the type system was too broad to be executed in a single step. To maintain robustness and high integrity standards, we took a strategic stepwise approach to the implementation. This led us to submit 2 change requests. The first allowed us to split the foundational work of Covenant into more manageable iterative milestones, ensuring that we had the ability to build everything solidly before moving forward. The second addressed the sheer complexity of our data type support, specifically with regards to the v3 Ledger API. By separating these into phases, we were able to prioritize functionality and documentation over more rigid adherence to the specific goals, and allow the project to be far more usable in its current form than it would have been had we stuck to the original timeline. Despite the technical complexity of implementing a new DSL from scratch, we stayed true to the original idea scale roadmap. We're proud to report that we delivered the reference implementation, extensive Haddock documentation, and a robust suite of tests. We'll now show that what exactly we succeeded in doing. Within Covenant itself, which is a library that does not depend on Haskell or Nix, as you can see, there is no Nix configuration anywhere in here. We developed a full library which has a primary entry point in covenant.asg. This provides a type designed to represent a Covenant serial form, as well as a range of functions that allow you to introduce and eliminate various computations. This can all be used to build up computations. We have extensive haddocks for everything used within that also explain how things can be used, and also within the code we have left several important notes to assist our developers in using the framework. Within the test directory, there is a whole range of tests covering a range of functionality, including some conformance cases for translation verification. Within the C2UPLC tool, we have a full code generator, which it can be found within the Covenant subdirectory, that performs verifications, transformations, and outputs C2UPLC, as well as an application which is designed to act as a front end by way of the CLR, by way of a command line interface, to translate Covenant serial forms into UPLC that can be executed. No direct requirement that the Covenant library be used to create this particular input is present. It can be created by another tool, and as long as the serialization format is correct, this will still work. Like with the Covenant itself, there is an extensive suite of tests provided, which is shown here, that verifies that various subsystems work correctly. The tool exists as current. You can download and use Covenant, the library, from Hackage, and you can find the source code, but the links provided to both Covenant and C2UPLC. Next, for Covenant, we will move on from the primary functionality towards delivering more practical applications. We will aim to implement static analysis tools, which will provide auditors with high-performance tools to trace how inputs like datum or script context field interact with contract logic. We will also make the capabilities of Covenant itself more friendly and easy to use, as well as potentially expand them to allow Covenant to be used not just for UPLC, but for other on-chain languages to help cross-chain operations. If you have any questions or feedback, or simply want to learn more about the Covenant project, please reach out via the links in the description.